Hi, I'd like to tell you about a project I've built called Margin Notes for automatic code documentation using recorded examples from runtime. I'm currently employed as a software engineer at a startup, and there have been a couple of things I've noticed at my job that have motivated me to work on this programming tool on the side. One thing I've noticed is that because the company I work for is 5 years old now, the limiting factor on how fast we can build stuff isn't really how fast we can write new code greenfield, but more often, how efficiently can we understand all this code that we've already written so that we can start modifying it? And that makes me interested in this question of how can we help software engineers understand the programs they've already written? Another thing I've noticed at work, though, is that despite all the wonderful research that's been done on this exact topic, the reality is that most programmers in the wild are not using sophisticated tools to understand their programs. In fact, there's a lot of expert programmers who have gone on the record saying they don't even use interactive debuggers and would rather just use print statements. So that leads me to this next question of how can we get people actually using sophisticated tools in practice to understand their programs? One idea I find interesting is the idea of taking a new approach and framing it in familiar terms. So when the car was first invented, it found success being marketed as the horseless carriage, which was just a way to communicate the value of the car to people who weren't used to it yet. And I'm interested in whether we can try applying this approach to programming tools as well. And today I'll show you an example of that. So in this case, the horse and carriage, the thing that we already find valuable, is usage examples. In my experience, usage examples are some of the most useful ways to understand some code. This can be at a high level, like in a library README, where it shows you examples of how to call the code and what that code returns. Or it can be at a lower level, so in the source code itself, it's often really useful above a function definition, for example, to have examples of how to call the function, and then also what that function returns when you call it like that. So these types of concrete examples can be really helpful for augmenting the abstract code and explaining what it does. The problem is, many libraries and codebases don't have enough documentation of this form. Can we do something about that? Well, when we look at these examples, the interesting thing is that they were essentially built by running the code and then copy-pasting the results of what it did into the text as a comment. Why are we doing this manually? Could we just automate this so that all the code we read all the time has enough examples? And that's the simple idea at the core of margin notes. We record execution traces as the program runs and use this as a source of example data. But we don't view this data in some sort of debugger type user interface. We want it to just feel like you're reading usage examples. So we show examples across multiple traces together to help build a broader understanding. And we show the examples right together with the code, so it's not in some separate UI and it really feels integrated. Let's look at how this works in practice. Here we have some code from a Ruby tic-tac-toe game that I wrote. And this is a method on the game class that says it returns a string representation of the tic-tac-toe board. This is some pretty simple code, but it's also not trivial to understand what it does. In addition to just needing to parse these 3 lines and wrap our heads around what it's doing, we also have some missing information. So we're mapping over this instance variable called squares, but if we don't know what's in that variable, we have no hope of understanding what this method could return. Let's see how margin notes can help. On the left-hand side here, we're just seeing a typical code editor, but all the functions are highlighted and we can click on them. And on the right-hand side, we're seeing the margin notes sidebar. Now when we click on a function, what we get in the sidebar is a list of actual function calls that happened in previous runs. And we can see the return value of the function here. So we're seeing examples of what that tic-tac-toe board actually looks like. On top of that, we can also dig into the state of the object at the time the method was called on it. So here we're seeing what that squares instance variable looked like when we called this method. And we can start to see how the internal state of the object related to what that method output. So from the sidebar, we instantly get a better sense of what the output of this method looks like, which is really useful if we're trying to use its results. On top of that, If we want to modify the implementation of this method, seeing examples like this is also really helpful. For example, we can see how those 12 dashes in the code end up becoming the horizontal line in the tic-tac-toe board. Now you might ask, how is this better than a code comment? We could have just copy-pasted that tic-tac-toe board and put it in a comment above this function. Well, for one thing, this is automatic, so we didn't need to do any manual work. We just played a tic-tac-toe game and got these examples for free. On top of that, by showing these examples outside of the code, we get a few advantages. So we get a lot more space to show multiple examples in a list, and we also get things like interactively inspecting objects and progressively displaying information. On the other hand, we don't require a whole workflow shift to use this UI because it's in a sidebar right next to the code. So the experience of seeing the examples remains pretty fluid, just like seeing examples in the code itself. A quick note about how this all works. I wrote a Ruby library that just records all the function calls that happen in certain parts of your program, including all the arguments given to a function, its return value, the state of the object, and so on. All of that gets serialized to JSON, and then we have a web viewer that shows those examples at the right place in the code. The important thing to note is that most of these are unimportant details. So this idea could work for other languages. You could also have different viewers for different contexts. You could see this information on GitHub or in your favorite IDE, for example. Now let's look at another example of how margin notes works in practice. Here we have another method from that tic-tac-toe game, and this one is perhaps even simpler than the previous one. We just have this method that checks if a given player has won the game by checking each of the 3 possible directions that you can win in tic-tac-toe. But this still leaves the question, what is this player argument here? Could it be some sort of player object, maybe just a string or a number? We don't know. Now we could go trace that down in the code, but why bother when we can just inspect some actual examples? Once again, we can click on the function and we see some examples. One where the player is the number 0, another one where it's the same, and then a third example where it's the number 1. So beyond just seeing that the type is integer, we're actually getting specific values that that argument has taken on in past runs. And if you can imagine if we saw these same numbers appear over hundreds of games that were actually played on a production server, then you might be able to infer that 0 and 1 are probably the main values that we use to represent the 2 players in the game. Finally, let's look at one more example. Those previous 2 examples were for code that I wrote, but you can also use margin notes to understand a third-party library. I frequently find myself reading code on GitHub for a library that doesn't have enough documentation, and I wondered whether margin notes would make it easier to understand code in that way. So here we have a code snippet from a Ruby library called Ruby Money, which is a library for dealing with currencies. And within the currency class, the library defines this equality operator for whether a currency is equal to another currency. Now, Ruby Money is a very well-documented library, so it actually has this great comment above the method that not only says what it does and what the expected types of the parameter and the return value are, but it even gives us a code example of how to call this method and what it does, which is great. But let's see what margin notes can provide beyond this. Now, in a tic-tac-toe game, it was pretty easy to record examples because we could just record as we played the game. But with a library, it's not as obvious how we can get examples that cover all the functionality of the library. One trick we can use, though, is to use the unit test suite, which is designed to cover all the code in the library. So what I did is ran the test suite for this library and recorded using margin notes as the test suite ran, which gives us examples for all the functions. So once again, we can click on the method, and in this first example, we see that the self, the object that received the method call, is a currency object representing the euro. And the other currency param that gets passed into the method is also a currency object representing the euro. So as expected, our method returns true for equality. Now in the second example, you'll notice that the other currency parameter in this case is not a currency object, it's actually a string representing the euro. But the method still works, it still returns true. What we're seeing here is basically an undocumented feature. So it's in the unit test suite, but it's not mentioned in the comment above the function which says that the other currency param is a currency object. What we're seeing here is a benefit of the margin notes approach, which is that when you're driving your examples from actual runs of the code, they're more likely to match the actual behavior of the code than manual documentation. We're also seeing that in a dynamically typed language, something like margin notes can be pretty useful for understanding the types in a program. Now obviously we can't put a ceiling on all the types that could appear in the future like you can in a statically typed language, but at least we can get a list of all the types that have appeared in the past, which is useful for at least making some initial assumptions about how a program works. I hope these examples have given you a taste of what it's like to use margin notes. I found it really useful personally myself, especially for reading library code like this, to have all these examples so easily accessible. That being said, margin notes is still a really early prototype, and I want to talk briefly about some of the limitations that it has and some ideas for what it could become in the future. First, what do we do when the code changes? So the old examples that we've recorded no longer accurately represent what the code currently does. Well, one helpful property we can take advantage of is that in many real systems, the code is actually executing pretty frequently. For example, on a web server that's constantly servicing requests. So as long as we're recording examples frequently, and we can filter down to recent examples in our viewer, that actually should be enough to be usually looking at reasonably up-to-date examples. This is pretty similar to using other tools that rely on looking at traces of execution, like a performance monitoring tool for a server, where you're much more likely to be looking at traces from today that represent the current performance than traces from a long time ago that might no longer be accurate. Another limitation is displaying side effects. The current prototype shows arguments and return values, but it doesn't show other stuff that functions do in languages that have side effects. Take this code example, where all this method does is set the value of an instance variable on an object, and that isn't captured anywhere in the margin notes sidebar currently. Now in a language like Ruby, there's no silver bullet solution to this, but there are some limited things we could try. For example, this code snippet represents a common category of side effects, which is mutating state on the receiver of the method. So for that category, you could do something like show a diff of the receiver's state before and after a method call. And you can see here, we show that diff, which helps us understand the behavior of that method. Still, this does miss a lot of other side effects, things like network calls or file system access. And so in a language like Ruby, we might just need to ask the programmer to explicitly register certain important side effects to get them to show up in the margin notes sidebar. Or we might need to switch to a different language that takes a more explicit approach. A third limitation is that currently margin notes just shows a list of examples. And when you get to hundreds of examples, it's really hard to gain insight about what's going on across them in aggregate. Now at this point, this becomes a data viz challenge. One simple idea we could try is, instead of a list, to show distributions of variable values across many runs of the program. So here we're seeing that across 40,000 runs of our program, the player variable is always 0 or 1, and it's roughly split 50-50. And this would probably give us a fair bit of confidence that we're using only those two values to represent which player is which. Or perhaps we might see that 1% of the time, player is nil. It's clear from the distribution that this is a fairly exceptional case. And we could then dig in further and start looking at specific examples of function calls where that value was nil, and try to understand what's going on there. To me, this is kind of reminiscent of filtering down traces in something like a performance monitoring tool, except instead of just performance data, we actually have real variable values in there, which really promote more understanding. And finally, Currently, there's no way to ask questions about the context of any given function call. Things like, why was it called with those arguments? What called it? Or what happened next after that call? So you could imagine using each of the individual function call examples as a starting point for exploring a single execution in more depth. Now, here I have a rough mock-up of what it might look like to explore a single trace in more depth. At the bottom, you have a stack trace over time where you can click on different parts of the execution. And up top, we have just the code for that function that's currently being displayed in the stack trace, as well as the arguments and return values similar to margin notes. This is just a rough example though, and at this point you could really start applying techniques from all of the work that's been done on visualizing single execution traces. Now before I wrap up, I do want to mention that there's a lot of related work that's around the area of this project in many different ways, much more than can fit on a single slide. There's been some great work in runtime visualization showing what programs are doing. A key difference between margin notes and projects like Seymour or Lighttable is that we visualize across multiple runs of the program simultaneously. And I think this is an interesting area to explore further in terms of how can showing multiple runs rather than a single run help promote a broader understanding of what a program does in a greater variety of cases. Another area of related work is in visualizing API usage examples. So the Exemplar paper, recently written by Elena Glassman and colleagues, focuses on the same problem of providing enough API usage examples to programmers, but it does it in a different way by synthesizing across multiple snippets of static source code rather than looking at runtime data. And finally, there's a really neat project called MonkeyType that's in production at Instagram. And MonkeyType is a Python system that observes runtime type data to automatically generate type annotation comments in the source code. And so that's pretty similar to margin notes in some ways. Two key differences are that margin notes goes beyond just the types and actually records specific values, which gives us a little more information to work with. And rather than shoving it into the source code as comments, we get a graphical sidebar to view the data in a more flexible way. And you can see references to these and even more examples of related work in the online essay version of this talk. So there's been all this great work on tools for understanding programs, but when I go to my job, I just don't see people using these tools. And this brings me back to this question of how can we get people to use sophisticated tools in practice for understanding their programs? The approach I have proposed here is to take something that we already know programmers find useful, usage examples, and to reimagine that. Part of the hypothesis here is that the familiarity of the framing makes it easier to communicate why this tool is useful. But I think it might extend beyond that too. By taking inspiration from tools that we know programmers find value in, I think it might nudge us towards building new tools that actually solve the real problems that programmers have in their jobs. There's an obvious danger here that we might be limited to only thinking of incremental improvements on top of existing tools. But I don't think our thinking has to be limited in that way, as long as we're just using the original tool as a loose starting point for inspiration. We can think about applying this approach to other tools as well. Take print debugging. Everyone says not to do it, but everyone does it. What can we learn from print debugging to bring into a new tool for understanding programs? One project I've been thinking about is a debugger that starts out working just like a print debugger, except under the hood, instead of just doing print statements, it's actually capturing a full snapshot of the program state at every print statement, so that later you can go back and inspect the state at the time of the print statement. You can start out using it just like a print debugger that you're familiar with, but progressively enhance your usage from there. And of course, there's many other tools that programmers find useful for understanding programs. So I hope this inspires you to reflect on what tools you find useful and how we might reinvent them. That's it for this video demo. You can find the full web essay version of this talk at that URL. And if you follow me on Twitter, I'll post further updates about this project as well as other research on programming tools. Thanks so much.